Good day, everyone. I am John Leeroy Gadiane, a college faculty from the University of San Jose Recoletos in Cebu, Philippines. I am also finishing my degree in Masters of Computer Science at the Cebu Institute of Technology University. My research is titled Implementing Emotion and Sentiment Analysis Using Twitter as a Corpus for Predicting Social Media Depression. The research focuses mainly on how the Twitter platform can be used to identify social media depression and use the behaviors shown by the users to determine whether we are able to predict social media depression. Together with me are my professors, Dr. Cherilyn Santa Romana, the Dean of the College of Computer Studies at the Cebu Institute of Technology University, as well as Dr. Larmi Feliscuso, the chairman for the IT department of the College of Computer Studies at Cebu Institute of Technology University. Depression has become one of the leading causes of disabilities around the world. At its worst, depression can lead to suicide. Close to 800,000 people die due to suicide every year. Suicide is the second leading cause of death in 15 to 29-year-olds. So this is all according to the World Health Organization, and with millions of people being affected, this has become an issue that must not be left unnoticed. According to Leah Liz, MD, a board certified psychiatrist, social media also contributes to depression. Having this in mind, the proponents has identified a social media platform that has a lot of active users, which is Twitter. We took advantage of this and made use of Twitter as a corpus for predicting using sentiment analysis. We get the tweets coming from the users that contain certain keywords. We then get the profile of the public users that made those tweets. With this, we got their Twitter feed and did some analysis. This process includes sentiment analysis and emotion analysis. We also got the date and time of posting, whether it was posted in the morning, afternoon, and evening. So this is to understand at which point of day are the users more active. So for data collection, this research uses crowdsourcing for the data. Crowdsourcing is the practice of retrieving data or information from a large density of population, typically via the internet. We used the Twitter streaming API to stream all the public tweets made by the users. The tweets that were considered relevant to the research contains the keywords of any of the following: diagnosed with depression, I have attempted suicide, I have depression, sad or depressed for a long time, or taking depression medication. We then got 5,000 tweets using this API. Then we extracted the distinct users. This process allowed us to identify the users who have claimed that they were diagnosed with depression. From these 5,000 tweets, we were then able to extract 216 distinct Twitter users. For methodology, before being able to use the data for data processing, it has undergone data pre-processing, which includes removing of links and symbols, and also we need to translate the language to English. Sentiment analysis, after data pre-processing, we were able to use the data for sentiment analysis. This is to get the positivity and negativity of the tweets. We first created a model which uses 1,200 public tweets that contains either a happy or sad emoji. All tweets containing a smiley emoji indicates a positivity sentiment, while a sad emoji indicates a negative sentiment. The training set is pre-processed to remove any unnecessary contents like the links, hashtags, and symbols. So with this, and using the multinomial naive Bayes algorithm, we were able to create a model that was able to accurately determine the sentiments shown in a tweet. in a tweet. In here, we have an example. So this is some of the tweets that we were able to gather using the Twitter search API. The first row, we have 22 American first. So if this isn't enough to get Republicans out to vote in November, I don't know what it is. So this tweet has a negative sentiment. So this is already applying the sentiment analysis to our tweets. After that, we actually proceed with the next step, which is the emotion analysis. The emotion analysis of the text is also a major factor in predicting social media depression. Emotion analysis is another field of natural language processing that deals with the understanding of the context of the tweet or text to identify the emotion portrayed by it. Each tweet is tagged with its corresponding emotion using the parallel dots API. So in our example, these are some of the tweets that we have, and then before we proceed with sending it to the parallel dots API, we actually need to also pre-process the data. As you can see, some of the words are not in English, so we need to translate it again using the Google Translate API, and then we would also need to remove all of the links and some unidentified symbols or characters. The Parallel Dots API has a text analysis feature specifically on emotion analysis. The API trains its classifier through the use of CNN or the convolutional neural networks using their emotion analysis dataset. The different emotions that can be captured based from the text are the following: happy, sad, excited, angry, fear, sarcasm, and bored. Each tweet is tagged based on the classified emotion. The figure below shows a sample of the tweets that have undergone emotion analysis through the Parallel Dots API. So for example, here we have the first row. It is classified as excited. The second row is classified as angry, excited, excited, fear, angry, fear, sarcasm, excited, so on and so forth. So with this, we already have our first and second step, which is the sentiment analysis and emotion analysis. So aside from these two, we actually need to consider a third option as well, or a third categorization as well, which is at what specific period of time are the users most active. So to determine this, we actually need to get or we actually need to get the specific time of day that the user posted that tweet, and then categorize it either by morning, afternoon, or night. So for the morning post, we classify the tweets that are posted within 5 a.m. to 12 p.m. as morning. Next, for those tweets posted 12 to 7, we classify it as afternoon. So 7 onwards until 5 a.m., we consider it as night. And then there is a hypothesis that most of those who are feeling depressed are actually active or more active during the night. So we are also trying to check this one out, and also in order to understand deeply, or in order to understand more the behavior of those who have social media depression. And then with this, we already can proceed with the next step. Now that we are already finished with the first part, which is getting the sentiment analysis, the emotion analysis, and as well as the period of time that the user is most active, we could already proceed with model creation. So there are many existing approaches in creating a predictive model. one of which is the multivariate linear regression model. This model greatly relies on the independent variables. The linear regression model determines whether there is a relationship between the independent variables and dependent variables or the response variable. The independent variables include the number of tweets, number of replies, number of retweets, the emotions shown in the morning, afternoon, and night, and the sentiment, which is positive or negative. Each of these independent variables are used to determine the probability for the classification. So this is the formula that I've been using in order to determine whether, in order to have our model. So in here, applying this formula, we could, as shown in this figure, among the variables that are in the data, only 11 are relevant to the prediction model. So this include the following. So angry M, which means angry morning. Happy M, which is happy morning. Negative, negative morning. Positive M, positive morning. Fear A, so fear in the afternoon. Neutral A, so neutral in the afternoon. Positive A, or positive in the afternoon. Bored N, or bored at night. Neutral N, neutral at night. And excited N, or excited at night. So we could say that these variables are relevant because only these variables have a p-value score less than 10%. So in this example here, you could see those with p-value scores of less than 10%. So considering this, another regression process is performed only using the relevant variables. So here are the following relevant variables that we have, which I've already stated earlier. So the result of the regression provides the different values that will be assigned as the regression coefficients. So since we already have the model, then we could already test it out. So we already have the results and testing based on the regression model that we have. So based on the regression results shown in this figure, a model has been created in order to predict whether a person shows signs or behavioral patterns similar to those who are diagnosed or claimed to be depressed. The results align with the hypothesis that emotions and sentiments have an influence in predicting depression. The model also shows that the behaviors and emotions that an individual show at night is a great factor in prediction. So this also supports the hypothesis that we had earlier, which is most of the users are actually active at night. So in order to test the fit of the predictive model, so we have a tenfold cross-validation. So cross-validation divides the data set into the training data and the testing data. So this tests the accuracy of the model and checks the RMSE, the R squared, and MAE values. So this figure shows the values of the model. So the figure shows that RMSE value is low. So this indicates that the model is a good fit for the problem. The figure also shows that the R squared value is high. So this indicates that the coefficients used for the model explains the dependent variable. So taking into account the different variables that is relevant to the predictive model, the sentiments and emotions play an important role in the prediction. Moreover, different roles or different emotions and sentiments are observed on different time frames, wherein the happy and angry emotions are observed in the morning, while the user's positivity is observed during the afternoons. So we also have the precision and recall accuracy and the F1 score of our model. so which is shown in here. This shows the precision, recall accuracy, and F1 score of our model. So it has the average of 0.93 or 93% precision, a recall of 77%, accuracy of 82%, and an F1 score of 84.5%. So to conclude this research, in this paper, the researchers aimed to develop a model that can determine whether a user has a tendency to be depressed through his social media behavior. The model created has an average of 0.845% F1 score and 82.6% accuracy. So this indicates that the model is reliable in identifying whether a person is displaying a behavior that is somewhat similar to those who have claimed to be diagnosed as depressed. We do need to take note, however, that some of the dataset gathered is based on the person's self-diagnosis. So as for recommendation of this research, it is recommended that for further studies, the dataset that we will be using should be from those who have been diagnosed as clinically depressed by actual doctors. Also, it would also be best if we could have um, we could get data not just from Twitter but also from different social media uh, social medias as well, like Facebook, um, Instagram, so on and so forth. It was also recommended that we do not use the English or translate our tweets and instead have it in English already, because with translation there are some tendencies wherein the thought of the sentence or the thought of the text or the tweet would actually be different from what is actually meant by the what is meant by the user. So that would be all for my presentation. So I have lots of references here, which is from Chowdhury, Volkova, and I'll be posting some of my references. So thank you all for listening to my research, and I hope you have a great day.